we're going to work on solving a standard maximization problem. So notice, to be a standard maximization problem, first we need to make sure it says the word maximize. That's pretty straightforward. The next thing we have to look at is make sure that we have non-negativity constraints. So see x1, x2, and x3 all say they're greater than or equal to 0. And notice those inequality signs for the constraints themselves are both less than or equal to. So this meets all of the conditions for a standard maximization problem. We start working our standard maximization problem by taking each one of our constraints, each one of the actual constraints, and turning them into equations instead of inequalities. And we do that by adding slack variables. One slack variable for each constraint. So our first inequality will look like x1 plus x2 minus s3 minus x3 plus s1 equals 6. And our second inequality or constraint looks like 2x1 plus 4x2 plus 3x3 plus s2 equals 18. So step 1, rewrite the constraints using slack variables. Step 2, rewrite the objective function, putting all of the variables over on the left side of the equation and all of the constants over on the right side. So rewrite the objective function. This will look like negative 7x1 minus 2x2 plus x3 plus p equals 0. You don't have to rewrite these, they're just the non-negativity constraints, so they don't make any type of decisions for you. Alright, now take these equations that you just wrote and turn it into a matrix. We have 3 equations, so we're going to have 3 rows in our matrix, and we have 1, 2, 3, 4, 5, 6, 7 different types of variables, so we'll have 7 columns for our matrix. If you want, you can go ahead and list all of those different variables first before you get started writing your matrix, and that way you have plenty of space for them. And there's our equal sign, and now I'm ready to roll. So up on this top equation, I have a coefficient of 1 for x1, 1 for x2, negative 1 for x3, 1 for s1. I don't have an s2, I don't have a p, and this was equal to 6, and that's the first row of my matrix. The second row looks like 2, 4, 3, 0, since I don't have an s1 in my second equation. So 0, 1, 0, and 18. And the last row looks like 7, negative 2, 1, 0, 0, 1, 0. So up above the line, I have my constraints. Below the line, I have my objective function. We start using the simplex method and solving this equation by looking for the most negative indicator. Oh, I left that negative off my 7 there. Looking for the most negative indicator. So negative 7 is the most negative number. That tells me that this is my pivot column. And then to find my pivot position, I find quotients of the constants divided by the coefficients from that column. So I have the constant 6 up on the top, it'll be divided by 1, and 18 divided by 2. Remember that your pivot position shouldn't be a 0, and it also shouldn't be a negative number. So if that happens, then those numbers are off, are out of bounds, I guess, for your pivot position. So it looks like 6 divided by 1 is our smallest quotient, so that makes this one our pivot position. Now what we do in pivoting is we're trying to turn this non-basic column into a basic column. So we want a 1 in our pivot position and zeros everywhere else. Lucky for us, we already have a 1 in our pivot position, so the next thing we need to do is get zeros everywhere else. So what we'll do is add a multiple of one row to another row. That's one of the things you're allowed to do in matrix algebra. So is there something I can multiply with 1 and add to 2 to get 0? The trick will always be to multiply by the opposite sign of the number you want to get rid of. So I want to get rid of a 2. I'm going to multiply this 1 by a negative 2. So negative 2 times our pivot row plus that row I want to change becomes a new changed row. And I also want to get rid of this, turn it into a 7. Into a 0. So the trick is opposite sign times the pivot row plus the row I want to change becomes a new changed row. You can use your calculator for all of this, and you don't actually have to do those calculations by hand. So if you'll hit second and x negative 1, notice it says matrx for matrix above it. Go over to edit, type in the size of your matrix. Ours had 3 rows, so I hit 3 and enter, and 7 columns, so 7 and enter. And then I just start typing in the coefficients from my matrix. And hitting enter after each one I type. Once you get those put in your calculator, you want to get out of the matrix window. We're done editing. So do second quit and onto programs and down to something called row ops. Hit enter and enter again, and you'll look, and hopefully what comes up is that matrice that you just entered into your calculator. So do a quick check using your arrow keys, scroll back and forth, and make sure all of the numbers that you put in there are the same ones that you have on your paper. If they're not, you're going to have to stop and re-edit your matrix. There's no point in continuing if your numbers are wrong. Okay, so I'm happy with the numbers that are in there. And if you'll hit enter, you have these commands or these operations that your calculator will do. It'll swap rows. It'll multiply every entry in a row by a single number. It'll pivot around a particular number. And the last one is to stop and get out of the program. What we're going to do, or what command we'll use every time we want to get zeros, is this to pivot function. So we're going to choose option number 3 to pivot, and we'll be pivoting around row 1, column 1. That's what we decided our pivot position was. So choose option number 3 to pivot around row 1, column 1. So I'm looking at these out of my calculator, and the new matrix I have looks like so hopefully your matrix looks like this as well. If not, something happened, we need to go back, we need to look. Maybe there was a number typed in correctly that we didn't catch. None of these numbers over here should be negative. These are the solutions to your problem. And remember, we had those non-negativity constraints. So none of these numbers should be negative over here on the far right. Now in the simplex method, if we have a negative indicator in our indicator row, that tells us that we actually haven't reached the maximum solution. So do we still have a negative indicator in our bottom row? We certainly do. So look for the most negative indicator, just like we did when we started this matrix. Negative 6 is our most negative indicator. And now we're going to look for our smallest quotient. But remember, I told you that your pivot position can't be negative and it can't be 0. So we actually don't even have to do the quotient because 5 is the only number that is not negative or not 0. Your pivot position will also always be a number above the indicator row. So none of these numbers down here will ever be part of your of where you pivot. So we'll do the same thing we did before. We want to turn our pivot position into a 1. The trick in matrix algebra to get a number to turn into a 1 is to multiply by the reciprocal. So the reciprocal of 5 is 1/5. And our pivot position, or this number we want to turn into a 1, is in row 2. So we're going to create a new row 2. In your graphing calculator, hit enter to pull back up those commands. Option 2 to multiply row 2, hit enter, by 1/5 and hit enter. So this is all taken care of by to multiply row 2 by 1/5. That's the command we use in our calculator. So I'm not going to rewrite my matrix, but I do know that this number is now a 1 because of this operation that I just did. So this is a 1, and the next thing I need to do is turn these two numbers into zeros. The trick for getting a 0 is to multiply by the opposite sign. So this is a -1 I want to get rid of. I'm going to do 1 times my pivot row plus the row I want to change to create a new changed row. I want to get rid of the -6. I'm going to do opposite sign times my pivot row plus the row I want to change to become a new changed row. To get these zeros and to turn this column from non-basic into basic is called to pivot. So in your calculator, you're going to choose option number 3 to pivot, and our pivot position is in row 2, column 3. So choose option of row 2, hit enter, column 3, and enter. And the matrix it yields is Alright, now let me cut off my bottom row here. Now, if we've obtained the maximum solution, there would no longer be negative indicators in our indicator row. So notice down here at the bottom, there are no longer any negative numbers. That means that we have reached the maximum solution. I'm going to go ahead and label my columns x1, x2, x3, s1, s2, and p. And I'm going to write down the solution to my problem. So x1 we've turned into a basic column. Go to the 1, go all the way over. That tells me that x1 is equal to 36/5. x2 is now a non-basic column, so it is equal to 0. x3 is equal to 6/5. s1 is equal to 0. S2 is equal to 0, and P is equal to 246/5. This is the maximum solution, and we have solved the problem using the simplex method.